Hey y'all, welcome back. Tonight's homework is all about graphing quadratic functions. Typically they're going to be in standard form, so let's get started. Number one says f of x equals x squared plus 12x plus 32. So first let's identify the y-intercept. That's going to be just the constant here. Anytime your function is in standard form, you could find the y-intercept by just looking at the number that does not have the x. So my y-intercept is going to be 0, 32. My x-intercepts exist when y is 0, so I do have to actually solve for these. I'm going to set my equation equal to 0, and then solve for x. So let's see, is this going to be factorable? We got two numbers that multiply to give me 32, add up to 12. Oh yeah, so that would be 4 and 8. So I'm going to rewrite this as x plus 4 times x plus 8. And then I can set each one of these equal to 0 and solve them independently. This is going to be how we find our x-intercepts. So our x-intercepts will occur when x is equal to -4 and when x is equal to -8. So my two x-intercepts are going to be at -4, 0 and -8, 0. Next up, we need to find the vertex. So to find the x-coordinate of the vertex, or our h value, it's going to be -b over 2a. Just as a little reminder there. So in this case, it would be -12 over 2 times 1, which would equal -6. -12 divided by 2 is -6. So that's going to be the x-coordinate of my vertex. The y-coordinate is going to be the value that I get when I plug in this particular x. So if I plug in -6 here, and I get -6 squared. See if I can scroll down just a tad here. There we go. -6 squared plus 12 times -6 plus 32. This is going to be something you're probably going to just want to put in the calculator here. We get 36. Let's see here, minus 6 times 12 plus 32. I'm just typing this in up over to the side here. I'm getting -4. So my vertex is at -6, -4. Now I'm ready to make the sketch. We've got all of our key points here. We've got the y-intercept. We've got the x-intercepts. And we've got the vertex. So let's go ahead and sketch this out. So the y-intercept is at 0, 32. That's going to be way up here. And again, I'm just doing a little rough sketch here. It doesn't have to be perfect. So I'm just going to plot a little point here. Maybe instead of drawing it, I'll use the circle feature. And I'll label that 32. Okay, my x-intercepts are going to be at -4, -8, so I'm going to label that down here. And again, we're just doing a sketch here. It doesn't have to be perfect. I'm just trying to get approximately where all these things are. And then finally, I've got a vertex at -6, -4. So that'll be, -6 here is going to be in between -4 and -8. And I'll try to make this as even as I can, -4 on the y-axis. So my point is going to be right about here. All right, that's pretty much it. Here's my parabola. going to do the best I can here with a mouse, so just, be kind. Oh, that's so bad. Oh, is that going to work? Ah, that's pretty close. Okay, there you go. There's our sketch for number 1. Let's take a look at number 2. All right, same basic setup here. Make sure you can see the equation. So I'm looking for the y-intercept, the x-intercepts, the vertex, and using all of that for the sketch. So my y-intercept, just like with the last one, is going to be whatever the constant is here, and that's going to be 8. So my y-intercept is at 0, 8. My x-intercepts will be the points where the graph crosses the x-axis, and this occurs whenever the y value is 0. So I'm going to set my equation equal to 0. Now factoring is typically easier when your leading coefficient's positive. So I think what I'm going to do is actually just multiply both sides by -1 and effectively flip all these signs. Okay, so to solve this, I am gonna try to factor this. I need two numbers that multiply to give me -8 and add up to -2, and that would be -4 and 2. So I get x minus 4 times x plus 2 equals 0. And so I've got x minus 4 equals 0, or x plus 2 equals 0. So x will either be 4 or -2. So my x-intercepts are going to be at 4, 0 and -2, 0. All right, next up is the vertex. So the vertex is going to be the point that is either the maximum or the minimum of the graph. The x-coordinate can be found by dividing b over -b over 2a. So b here would be, well, let's go back to the original function here. It would be 2, and then a is -1. So -2 divided by -2 is +1. For k, or the y-coordinate of the vertex, we are going to plug in this h back into the equation. So -1 squared plus 2 times 1 plus 8. Probably want to use a calculator, although this one's not so bad. You could probably get away with not using the calculator. -1, or I'm sorry, 1 squared is 1. We have that negative hanging out in the front. So this is going to be -1 plus 2 plus 8. So -1 plus 10 is going to be 9. So our vertex is at 1, 9. For the sketch, I'm going to first plot my y-intercept at 0, 8. I'll just plot it somewhere up here, so we have somewhere to start with. And I'll label it with an 8. My x-intercepts are at 4 and -2, so I've got one that's going to be roughly over here. Yeah, I guess that's fine. There's my 4. And then -2 would be like here-ish. My vertex is at 1, 9, so that's going to be, over 1, up 9. It's going to be just over where I have this 8 here. So I guess I'll put it like right about here. And you can kind of see what's going to happen with the parabola. Once you have those 4 points plotted, you should be pretty much good to go for the sketch. All right, there's number 2. Number 3 is x squared minus 4x plus 4. My y-intercept is going to be, again, that constant, so 0, 4. My x-intercepts, I'm going to get that just the same way that I did in the previous 2 problems, where I set the equation equal to 0. And then try to solve by factoring. If you can't solve it by factoring, it's possible that you'll have to use the quadratic formula, but I'd always suggest at least trying to solve it by factoring first. So 2 numbers that multiply to give me 4 and add up to -4 would be -2 and -2. So I get x minus 2 twice. Now I'm just going to set one of these equal to 0 because they'll both give me the same x value, which is going to be just +2. So my x-intercept here is 2, 0, and I only have one of them. That means that this is going to end up being the vertex. But let's just verify. h negative b over 2a is going to be -4 over 2a, 2 times 1. So 4 divided by 2 is 2. Like I said, we already know it's going to be 2, 0, but just to verify. K is going to be what I get when I plug in 2. So 2 squared. I'm expecting 0. And if you're wondering, like, how do I know that that's going to be the same as the x-intercept? When you only get one x-intercept, that means that that point has to be the vertex. So if this ever happens where you have the same factor twice, then your x-intercept and vertex should be the same. If you're getting something different, then you might want to double check your calculations here. We have 4 minus 8 plus 4 is in fact 0. So the x-intercept is actually the same point as the vertex in this one. Now we've got everything we need to be able to sketch this out. I'm just going to box all my key points here. I've got one point at 0, 4, that right here, and label it. Always important to label your graphs, especially when you don't have a grid. The x-intercept is going to be at 2, 0, and that is the vertex. All right, so our parabola will look something like this. Just barely touch that x-axis. All right, there's number 3. Number 4 has a y-intercept at -3. So that point, or that set of coordinates, is going to be 0, -3. To get my x-intercepts, I'm going to set the function equal to 0 and solve. So 0 equals x squared plus 2x minus 3. And this one can definitely be factored. Our two factors would be x plus 3 and x minus 1. Notice those two numbers multiply to give me -3 and add up to 2. So either x plus 3 equals 0 or x minus 1 equals 0. So our two x-intercepts are going to have x values at -3 and +1. I do like writing my x-intercepts as coordinates here, just to emphasize the fact that they are points and not lines. So -3, 0, and 1, 0. Now let's find our vertex. So our vertex is the point, in this case it's going to be a local minimum. And it's the point where the slope of the parabola changes from either negative to positive or positive to negative. In this case, it'd be from negative to positive. But let's go ahead and compute it. h is going to be negative b over 2a, so that'd be negative 2 over 2 times 1. So negative 2 divided by 2 is going to be negative 1. So that should be the h. And then the k will be what I get when I plug in this number back into the equation. So negative 1 squared plus 2 times negative 1 minus 3. This is going to give me 1 minus 2. So we're at negative 1 minus 3 is negative 4. Feel free to put that in the calculator just to double check. So my vertex is at negative 1 comma negative 4. Now I'm ready to do my sketch. My y-intercept is at 0, negative 3. I think this is the first one that had a negative y-intercept. Just put it down here. Label. Always important to label. My x-intercepts are at negative 3 and at 1. So here's one of the x-intercepts is going to be somewhere over here at negative 3, and then another one at 1. I'm just kind of estimating here, y'all. And then for my vertex, it's at negative 1 comma negative 4. So I'm going to try to label those as well. Negative 1 would be like roughly here. Negative 4 should be just below the negative 3. And so that coordinate would be negative 1, negative 4 is about right here. So you can kind of see what's going to happen with the parabola. So let's try to draw this one out. Go all the way down. Hit that vertex, come back up, and there we go. There's number 4. All right, we're on the last page now. Looks like there's just 2 more to go. So number 5, the y-intercept is going to be negative 25. 0 comma negative 25. For our x-intercepts, this is going to be one kind of similar. Was it number 2 or number 3? It was number 2 that had the leading coefficient as a negative 1. We have that same deal here. So when you go to solve it, like I said on that previous problem, it's typically easier to do the factoring when your leading coefficient is positive instead of negative. So to sort of help that out, to actually make that happen, we need to multiply or divide both sides by a negative 1. 0 times negative 1 is still going to be 0. So we can still use zero product property and all that and solve it like we would normally. And then multiplying everything on the right by negative 1 is just going to change all those to positive numbers. So 2 numbers that multiply to give me 25 and add up to 10 are going to be 5 and 5. So we have x plus 5 as, well, both of the factors, which means we're only going to have one x-intercept here, and we talked earlier about what's the significance there. When you only have one x-intercept, that means at that point is also going to be your vertex. So my x-intercept here is at negative 5. And while I already know what the vertex should be, we are going to verify that by computing it the same way we computed all the other ones. That way, if I made a mistake, this is where I'm going to catch it. So negative 10. Remember, it's negative b over 2a divided by 2 times negative 1. So yeah, 5 divided by negative 2 is going to be negative 5. So far it's looking good. I'm expecting my k to be 0 here, but let's make sure. Negative 5 squared, too many negatives there, minus 10 times negative 5, minus 25. So let's just make sure that is what it is. Negative 25 is negative 50, plus 50 does come out to be 0. So my vertex is in fact at negative 5 comma 0. Which is what I was expecting, so this is all good. Okay, so I've got my my key points here, y-intercept, x-intercept, which also happens to be the vertex. Let's go ahead and start plotting here. Now I know the leading coefficient here is negative, so I know it's going to be a parabola that opens down. So just keep that in mind as you're plotting everything. I'll put negative 25 way down here. Pretty much as far down as I can. Negative 25. And then my x-intercept, which is also my vertex, is at negative 5. All right, so my parabola, since I know it's opening down and I know this is the vertex, it's got to do something like this. Okay, there's number 5. Number 6, last problem here. Here's another one that has a negative leading coefficient, so just keep that in mind when you're solving the x-intercepts. The y-intercept here is going to be 4, so 0, 4. And one last time that we get that y-intercept from the constant here. The x-intercepts, I'm going to set my equation equal to 0, so 0 equals negative x squared plus 3x plus 4. To make the factoring a little bit easier, I'm going to multiply everything by negative 1, which I've done on a couple of these problems, so hopefully by now you kind of get the hang of that. Minus 3x minus 4. So now I am going to factor by finding two numbers that multiply to equal negative 4 and add up to negative 3, and those would be negative 4 and 1. So x minus 4 times x plus 1. So either x minus 4 can equal 0, or x plus 1 can equal 0. So my two x-intercepts are going to occur at 4 and negative 1. So far, all these computations have worked out really nicely. We haven't had any like fractions or square roots or anything like that. That's pretty nice. 4, 0, and negative 1, 0. All right, so here's the y-intercept. And the x-intercepts. And now let's find the vertex. So to find the x-coordinate of the vertex, we're going to divide negative b over 2a, which in this case would be negative 3 over 2 times negative 1. Oh, I was just commenting, and we have not had any fractions yet. Look at that. So negative 3 over negative 2 is going to be positive 1.5, or 3 halves. But I think for graphing purposes, the 1.5 is probably going to be a little easier to visualize. Okay, let's go ahead and plug in the 3 halves everywhere. So we have negative 1.5 squared. Let's see what the rest of the equation was here. Plus 3x. Okay, so plus 3 times 1.5 plus 4. And I'm definitely going to put this one in the calculator here. So negative, and then open up the set of parentheses, 1.5 squared plus 3 times 1.5 plus 4. And that gives me 6.25. So yeah, my vertex here, thought we were going to get away with no decimals in the whole homework. Not so much here. But it's really not that big of a deal. We're just kind of estimating where these points go anyway. So, these numbers are still pretty, in the big scheme of things, still pretty friendly. Now we can plot all of our relevant points here. The y-intercept is at 0, 4. I'll just put that like roughly here. My x-intercepts are at 4 and negative 1. So 4, I'm just going to see if I can't make this as even as possible here. Let's see. That looks pretty good. And then 1, maybe, or negative 1, maybe right here. And then my vertex is going to be at 1.5, 6.25. So I'm just going to mark that on my number line. 1.5 is going to be, right around here, and then 6.5 or 6.25 put like right here. So my point is going to be, well, let's move over that 6.25 because I think it's going to pretty much be exactly where that is. 1.5 comma 6.25 is going to be roughly like here. All right, we can draw our parabola. This is going to be it, y'all. This is going to finish up our homework tonight. So we had 6 problems where you had to find the y-intercept, the x-intercepts, and the vertex, and then sketch your parabola. Hopefully this video was helpful. If you have any questions about any of these problems, please reach out and I'll be happy to help you. Other than that, thanks for watching and y'all have a great day.